Okay, so the next one says to rewrite an exponential form. So we're just going to work backwards, from what we had before. When you're given this or this, then you can rewrite that as a to the m over n. So it's just backwards of what it was before. You can also do it with a fraction. If it's 1 over a radical, then it's just going to be the same thing, except for that fraction up in the power is now going to be negative. So here on 13, we've got the 5 out here. That's our n. There's no number inside, so we assume it to be a 1. So this becomes 10 to the 1/5 power. Okay, this next one, there's a 2 out on the shelf. Now inside, we've got more than one thing. Everything that's on the inside gets considered as part of the thing being raised to the power. So that 5xy has to be in parentheses. And it's the square root, and there's no powers on the inside. So it's just going to be 1/2. Okay, same thing with this one right here. We've got stuff on the inside. This time it's got parentheses and a 5th power. So that 5 is going to be your m. 4 becomes your n. And then this stuff inside is what's going to be raised to that power. So it will be 5 over 4. Okay, 16's got a 13 on the inside, and the number on the shelf is the 2. And then there's also the 5. So since this is the power outside or inside, it doesn't matter, that's your m. The shelf number is always your n. N is in Nancy. M is in Mary. So this is going to be 13, and that's to the 5/2 power. Okay, here we go. We've got a -1, right? So let's look at just the bottom. We've got 4x to the 7th power, and then a 3 out on the shelf. That's going to be 4x to the 7/3. And then since it's a fraction, we make it negative. Okay, this one's a little different. It's got this -2 out in front. Doesn't matter. All we're doing is changing this radical form. This is what we're rewriting. So it's going to be 5x. It's both inside and it's raised to the 3rd power, so it's 3 divided by the shelf number, which was 2. And then this -2 just gets written out in front. So converting back and forth, have those formulas ready. All right, adding or subtracting radicals. Here's the rules. The shelf number and the inside stuff must match. If they don't, you cannot add or subtract them together. If they do match, then you add or subtract the outside numbers only. And then you would try and simplify your answer. Now, what if in the beginning this do not match? If insides don't match, then you're just going to break it out, see if you can break somebody out of jail until they do match. So you're going to simplify, which I mean break out, to see if they do match. So, for example, this one here, right here, 19, we've got 4 square root of 18 plus 2 square root of 32. 18, 32 don't match. They are both square roots, so we're good there. But we're going to have to take these and break them down. So I'm going to take out here, let's do 4 square root of 18. Breaking down 18, it's 2 and 9, 3 and 3. Looks like we've got 2 3s. Group those together. 1 makes it out. have a 2 left over inside, and then don't forget this 4 getaway driver. So this is the same thing as 12 square root of 2. So this equals 12 square root of 2 plus, okay, let's try this, 2 square root of 32. Have to break down 32. 16. Oh, why does it do that to me? Why does it get up and move? Ugh. 4 and 4, 2 and 2, 2 and 2. So it looks like inside we've got 5 2s. Group of 2s. There's 1, another 1, and there's going to be 1 left inside. And then don't forget the getaway driver. So this simplifies down to 8 square root of 2. Now if you look at them, their insides match, their shelf numbers match, so we can finish combining those guys together by taking the 12 and the 8, adding those guys only, and then you put whatever it is that had to match next to it, and that becomes your answer. Okay, this next one, they don't match, so again I'm going to take this one and try and break it down. 2 and 6, 2 and 3, so that's actually 2, 2, 3. Got a pair of 2s. 1 makes it out. 3 stays inside. 5's on the outside. We can combine those guys together. So this is the same thing as 10 square root of 3 minus 6 square root of 3. Okay, the stuff outside, or sorry, the shelf number and the stuff inside matches. So we can combine the numbers out in front. Only the numbers out in front. The inside stays the same. And that's it. Now this one looks a little bit different. If we were to convert this to radical form like we did on the previous ones, it would look like this. This one would look exactly the same. So do they match on the shelf and inside? Yeah, I mean if you look at these guys inside the parentheses, they're exactly the same thing. So you can combine them as is, and it'll be 11 minus 6, that's the numbers outside. So 5 parentheses 3 to the 2/7 power. And that's it. No more simplifying beyond that. Okay, here's another one. This time the group size, the shelf number is 3, but they both have it. So I'm going to break down this 40. Looks like I've got a group of 3 3s and a 5. So 1 makes it out. That poor 5 is left inside. So the problem now looks like this. We had 8 cubed root of 5. Whoops, that's not a 3. Cubed root of 5 plus, and we broke that guy down, found out he was the same thing as 2 cubed root of 5, which means yes, now we can combine those guys together. There's 8 plus 2 of them, so 10 cube roots of 5. That number inside never changes, neither does the number on the shelf. Okay, as far as multiplying goes, here's the rule. The shelf number has to match. They must match. And that's the only requirement. Once they do match, so 1, shelf number, 2. Now you're going to combine the outside numbers. You're going to multiply them. Oh, yay for my dog. Sorry about that. I'm sure they'll bark again or whine or something, but hopefully we can ignore them. Okay, so we're multiplying the numbers that are on the outside together, and then you're going to multiply the inside numbers, and then you're going to simplify that result. So here's an example. Let's see, we're going to look at first the shelf numbers. These guys match, okay? There are no numbers on the outside to multiply together. So we're going to combine the inside numbers into one radical, 12 times 8, or the fourth root of 96. Now, here's this last step. Now it's just like the problems on the front page, right? At the very top, when you were simplifying the expressions, right here, that's all you're going to do with this answer. Is you're going to try to see if anybody breaks out of jail right here. So that's what I mean by simplify. Break out. Break out. All right, 96. Oh, I know what multiplies to it. 12 and 8. You actually don't have to multiply them together before you break them down, but you can. So we've got fourth root. Looks like we've got 1, 2, 3, 4 2s and a 3. Okay, group size is 4. 1 makes it out. Left over is the fourth root of 3. So that would be your final answer right there. Okay, next one. No numbers outside. The numbers on the shelf match, so we can join them into one single radical. And again, you don't have to combine them together just to break them apart again. You can factor these two separately and just put those into one radical and list them all together. I mean, as is 6 and 81, there are no 5s inside there. But once you join them together, you've got 2 times 3, there's the 6. And then the 81 was 1, 2, 3, 4 3s. So 1, 2, 3, 4. Okay, looks like we've got a group of 5 3s. 1 makes it out. Then left over on the inside is that poor little 2 all by himself. All right, next example. This one we've got 3s on the shelf, so that's good. Now we've actually got an 8 times 2 here, so that can go on the outside. And then for our number pieces, we're going to combine them into one radical, 45 times 35. Okay, and then we're going to break those down. That's 5 and 9, 3 and 3, 5 and 7, and that's it. So it looks like this guy is 3, 3, 5, 5, 7. Uh-oh, we're looking for a group size of 3. There aren't 3 of anything, so we're just going to have to leave it as that number. So that is actually the cubed root of 1,575. Don't forget this guy outside, the getaway driver, and that's it. There weren't any groups of 3 homies, so nobody broke out, and that just became our answer.